Welcome! In this video, we get a brief overview of the power and flexibility of Drupal's database API. We'll experience how to build database queries programmatically so that you do not have to hard code SQL statements. This video gives us concepts we should be familiar with so we can launch ourselves forward in the upcoming database videos. You are encouraged to examine the code samples displayed to strengthen your understanding. If you come from a background where you've queried the database directly using native functions like MySQL query or Postgres query, then the Drupal database API might seem a little strange at first. The goal of the API is to allow developers to write one query that will work across multiple types of databases. The Drupal database API provides a standard, vendor-agnostic abstraction layer for accessing database servers. In fact, unless you are developing Drupal core APIs, you should almost never be making database calls directly. Woohoo! This means that we do not need to be experts in writing database queries. So, when you encounter the term Drupal database API, what is really meant is Drupal's database abstraction layer. This layer provides a unified database query API that is capable of interacting with different underlying databases. So instead of having to keep in mind the nuances of writing multiple queries, for instance, MySQL, MariaDB, Postgres, instead you write one query object, and then behind the scenes a Drupal plugin has been developed to translate that query object into the appropriate database query to execute. This is exciting. Note that Drupal's database API is built on PHP data objects, called PDO. PDO is a lean, consistent way to access databases. This means developers can write portable code much easier. Okay, so far we know Drupal's database API provides a unified syntax for database queries. This means regardless of the underlying database vendor, the database query code we write doesn't have to be specific for it, which is awesome. In addition to that, the database abstraction layer also provides an object-oriented way to construct complex database queries, and it protects the database by using good security practices. Every database which Drupal connects to has a single connection object associated with it. To access a connection object for the active database, the code is straightforward. Use. Essentially, these two lines of code are two ways of saying the same thing, like tomato, tomato. I personally prefer to use the shorter \Drupal : database. You may also come across the following line of code, which uses the method getConnection. For practical purposes, at this point in our learning, it's the same, and with time and experience and situational context, you will be able to distinguish the nuances between them. Alright, continuing on. Once we have a connection object, we can begin to construct database queries with it. First, let's understand the two styles of Drupal database API queries: static queries and dynamic queries. Recall, a query is a statement that will be sent to a database connection so the database can perform the instructions of the query. Static queries will likely look similar to other native database queries you may have encountered in the past. There are just some minor nuances to keep in mind when you're using them in Drupal code. Also note that static queries should only be used for performing simple select queries. Static queries should not be used with insert, update, or delete queries. Dynamic queries, on the other hand, are quite different to static. The idea behind them is that you can build up a query step by step, based on different logic conditions in the code that you are working in. You can change the query dynamically as needed. Let's dive into examining these query styles. Most select queries in Drupal are static queries using the query method of a database connection object. Static queries are passed to the database nearly verbatim. So, for example, in this query here, we are selecting the fields of ID and example from the cool table table. Remember, that only very simple select queries such as this should be using the static query method. You should use a dynamic query if you need more complex queries. Said another way, only use the query method on a database connection object for simple select queries. I can't stress this enough. Do not use the query function for insert, update, or delete queries. Those should be handled via the insert, update, and delete methods, respectively. All right, awesome effort from you in learning. Dynamic queries refer to queries that are built dynamically by Drupal rather than provided as an explicit query string like we just saw with the static select queries. Note that all insert, update, delete, and merge queries must be dynamic. The typical structure of a dynamic query will look something like this. First, on the database connection object, you perform an operation method, such as insert, update, delete, or merge. And then, using that query object, you add some conditions, some fields, some other possible operations depending upon the original operation. Let's now compare the code of a static query versus the code of a dynamic query to compare the differences. For this example, let's query the user table to get the user ID, name, and created date timestamp for the first 50 registered users on our site. The code of the static query would look like this. Notice that this static query is very close to writing actual SQL code. We include the UID not equal to 0 because 0 is defined for the anonymous user ID. For comparison, let's examine the code required for the same query using the dynamic query builder. Realize that we still begin with a database connection object called database, and then we initiate the query using a method called select rather than the method called query. After instantiating the query object, we then call the condition method to say we do not want to include the UID of 0. Next, we call the fields method to identify the fields that we want. And then we perform the range method to limit the query to the first 50 users. The final step then is to execute the query to obtain the results, if any. As you can see, the code for this is abstracted away from the actual SQL code, and most programmers would be able to read the code and understand what is going on. Usually, the dynamic query generator code is simplified into one executed line of code. Here is the simplified version of it. Now that you have seen the typical format for a dynamic query and have seen an example using select, know that the other query types are performed likewise. To begin an insert query, use insert. For an update query, use update. Notice that this is always performed on the database connection object. For merge queries, where you want to conditionally either insert a record if it does not yet exist, or update the record if it does exist, use the merge method. And unsurprisingly, the delete dynamic query will begin in a similar fashion. After you begin the dynamic query, you can add fields, conditions, and other options to the query as appropriate. Be sure to look at the appropriate documentation for each. Always remember the final step of a dynamic query is to execute the query to obtain the results, if any, from the database. To execute the query, simply add the execute method to the query object as the final step to obtain the results. After executing a query, the result variable is an object that may be iterated over, most commonly using a for each loop. For example, to iterate through the results, you could use the following code. After we have executed a query statement, you can perform additional actions to the result object to obtain results instantiated in various ways depending upon your needs. We won't go over all these in detail during this video, but please visit the URL shown and provided again at the resources at the end of this video. Some common result actions are fetch all, fetch call, and fetch assoc. Fetch all returns an array containing all of the result set rows. Fetch call or fetch column returns an entire single column of a result set as an indexed array. And fetch association, fetches the next row and returns it as an associative array. In upcoming videos, we will use fetch all and fetch call. For good end-user experience, I recommend wrapping most every database query in a try-catch statement. This is because databases themselves have the potential to act in a manner beyond the control of Drupal. The database API throws an exception on error which can be handled with a try-catch code block. An example is shown. For the exception class, notice the \exception $e. If you would prefer not to type the backslash, be sure to include the exception class with a use statement. Fantastic! Epic effort from you in learning this stuff. In this video, we were introduced to the capabilities and flexibility of Drupal's database API. We learned that it is also called the database abstraction layer. Remember to use \Drupal : database to obtain a connection object to the active database of Drupal. It is this object that you use to begin building each database query. The key takeaways are that there are two types of database queries: static queries and dynamic queries. Static queries should only be used for simple select queries, and dynamic queries should be used for everything else, including insert, merge, update, and delete queries. Never use the native PHP database functions to query the database when working with Drupal. So this is all for now. There was a lot of learning in this video. Give yourself some credit for sticking with learning Drupal module development. Take a look at the resources provided for more. Happy learning!